The equation 24x squared plus 25x minus 47 over ax minus 2 equals negative 8x minus 3 minus 53 over ax minus 2 is true for all values of x does not equal 2 over a, where a is a constant. What is the value of a? Yeah, I'm not going to lie. This one takes a little extra writing, a little extra calculating here, a little extra time. It's definitely one of those where if I was under a time constraint, if I was afraid I wouldn't finish in the time allotted, I would circle this on my test booklet, because this is the paper version here. I would circle it, I would do the rest of it, and I would come back at the end if I had time. Anything that you look at and you do not immediately go, oh, this is going to take me a minute or less, or a couple minutes or less, those are usually best saved till the end. Do all the ones that are the quick ones first to make sure you get those maximum number of points. Now, first, the part here where they say x does not equal 2a, all that is telling you is, or 2 over a, excuse me, that it's not going to have a 0 in the denominator there. So you don't have to worry about that. Because if you put 2 over a in there, you're going to end up with, it's going to end up with 0. So we don't want that. So cool. Now that we know there's no 0, we have to worry about getting rid of these fractions because, fractions. We don't want fractions in this when we're trying to solve it, especially because we have some that are fractions in this one, the negative 8x minus 3, that isn't. So how do we combine everything and get rid of that fraction? First, we got to make this into a fraction before we can get rid of it. I know, it's crazy. So negative 8x minus 3, we want it to have that same denominator. When you want to give a denominator to something that is not currently in a fraction, you're going to multiply by that denominator over itself. Because anytime you do that, like if 5 over 5 or 5k over 5k, whatever it is, if it's the same thing over itself and it's not 0, then that's equal to 1. And you can multiply anything by 1 and it doesn't mess anything up. It's fine. So this denominator is ax minus 2. So we're going to multiply this by ax minus 2 over ax minus 2. That's equal to 1. We can do it. To multiply by this, we need to turn it into a fraction. So we're going to put it over 1. So on top, this is a FOIL situation. You're going to distribute, do your first terms, your outside terms, your inside terms, then your last terms. That's the FOIL acronym. It also just means distribute. All right, so first, negative 8x times ax is negative 8ax squared. Our outside terms, negative 8x times negative 2 is positive 16x. Inside, negative 3 times ax is negative 3ax. Last, negative 3 times negative 2 is a positive 6 all over ax minus 2. And then we have over here, I'm just going to bring down the other components of this. That's the 53 over ax minus 2. And that's equal to 24x squared plus 25x minus 47 all over ax minus 2. Okay, since on the right-hand side, they now have the same denominator, we can combine things. Because I can do that with fractions. So I'm going to combine it. Yay! There we go, minus 53. Now, because these are both over the same denominator on both sides, I can get rid of it. That denominator is out of here. The reason you can do that is because I am saying I am multiplying everything by ax minus 2. When I multiply this by ax minus 2, it gets rid of this because this is saying divided by ax minus 2. I multiply by ax minus 2, it gets rid of it. Same exact thing happening on the right. I multiply all this by ax minus 2 because I have to do the same on both sides. And since this is all being divided by ax minus 2, multiplying gets rid of it. Thank goodness. All right. So that's now gone. Yay! Be gone, foul fraction. Now, what can I combine? What like terms can I combine? Well, over on the right, I have two constants, positive 6 and negative 53. If I add those together, I get a negative 47. And looky there, on both sides, I have a negative 47 on both sides. So if I add 47 to both sides, both of those 47s disappear. Woohoo! Now look at this. And that negative looks really bad, so we're going to do boop. There we go. 24x squared plus 25x equals negative 8ax squared plus 16x minus 3ax. What they want you to realize here is we got rid of the negative 47s, and they were identical. Negative 47 on both. So nothing really weird is happening. If those numbers had been different, it would mean that these bits, were not equivalent to each other. But because they were both negative 47, these are equivalent. But that also means that each term, if you're talking about powers, the x squareds are equal to each other. The x's are equal to each other because those negative 47s were equal to each other. If there was something funky or strange going on, those constants would have been different. So all you have to do at this point, after all that mess, is just look at these two and set them equal to each other. So on the left, you have 24x squared, and it equals negative 8ax squared. I can divide both sides by x squared, and that gets rid of those x squareds. I'm left with 24 equals negative 8a. To get rid of that negative 8, I divide both sides by negative 8, and a is equal to negative 3. And if you want to double check that this works, you can double check it by looking at these second terms. See what happens if you plug negative 3 in right there. Then it becomes negative 3 times negative 3x, or positive 9x. And does 16x plus 9x equal 25x? Yes, it does. So that's confirmation that that is accurate. So that's a long walk to get to just a equals negative 3.
If this was helpful or useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.